Good morning, good day to everyone. So today we are going to discuss about the uh, Networkers Champ Interview question and answer part two. And in this basically part two video, we would be talking about the DHCP, DNS, TFTP, SFTP, SNMP, SMTP, and POP3. This video will be completely based on the real-time interview questions and answers that interviewer expect and interviewer ask, right? So you can pause the video anytime just to read out the context of whatever it is there in the PPT. I would be using couple of slides or couple of actually documents to basically answer the question. I'm sure if you go through this video and if you completely follow it, I'm sure you would never ever fail any interview, from at least these topics that I have given, because I have mentioned each and everything that the interviewer may ask you an interview, whether it is fresher or whether it is experienced. We have targeted in this basically from the experienced as well as freshers. So we'll start from the basic and then we will talk about other scenario based questions that interviewer usually ask. Okay, so let's get started with the DSCP. Right. So the question number one, what is DSCP and how it works? Right. So the DSCP basically is a dynamic host configuration protocol, right? Is used to provide the dynamic IP address to the client's host machine. Now, if you remember, we discussed there are two ways to assign the IP address, manual and automatic. This is the automatic way actually, right? To provide the IP address. Okay. Now the question is how it works. This is very important, and then we will get into, the other questions. So how it works, we all are aware of this DORA process, right? So in this basically DORA process, what happens exactly? So let me just go through this. Oops, just give me a moment. Okay. So DORA process basically what it is exactly, and we would also see what packet that it goes, right? And then what type of packet it is there in the header. And the same you can also verify using the Wireshark, right? It is important to understand whenever DHCP messages are sent and received. Let's say in this case here, we have this DHCP, discover. So what happens? The client basically, let's say when you select on this computer to obtain the IP address automatically, right? What is the first thing this client does? This client would send a discover message. It will discover, who is DHCP server. And, so how the discovery will happen? So discovery will happen. There would be basically layer three, right? In layer three, you will have source IP and destination IP, right? Source IP is always because it doesn't have any IP address. It will be always 000 as you see here, and the destination IP would be always 255.255.255.255. That is broadcast. That is the layer three. Okay. What about the layer two? Again, the source MAC. Right, the source MAC would be the MAC address of this machine, whatever the MAC address is, and the destination MAC address would be, as you see here, uh, 12 times FFF. That means this is basically called a layer 2 broadcast. Okay, this is layer 3 broadcast. This is layer 2 broadcast. Now, this was basically about the layer 3 and layer 2. The DHCP is pretty much, it works on the layer 4, right? And this is where it would use the source port and destination port as well. On this source port, so client side, the source port would be 68, and then the server port would be, destination port would be 67. So the layer 4 would be source port, right? 68 and destination port 67. On basically with this information will be carried right over the Ethernet, and discover message would be sent. Now let's say there could be two instances. Either the router is the DHCP server, or Windows server is acting as a DHCP server. Let's assume Um, a very basic example, this is switch. I know this is little time consuming, but anyways, I have to. And this is router. We configure, we can configure DHCP on the router also. Okay, so let's assume that the router is acting as a DHCP server. So obviously, the message would go to the DHCP server. Finally, the discover message. DHCP server, actual DHCP server would send the offer. Okay, because it has received the discover, right? So when a server receives the discover request, then it responds with the DHCP offer request to the client, right? And offer basically contains some information like the IP address that the lease duration that host can use, right? Well, lease and for how many days, for how many hours actually that IP address would be valid, right? What is the range of the that IP address that it has, right? All that information would be sent in the offer. But what is important here, again, so when the DHCP server is responding to the client, right? What would be the layer 4 information? So layer 4 would be source port would be 67, destination port would be 68. Layer 3 would be source IP. Now remember, the source IP would be, even though this router has its own IP address, right? Because server, it is server, right? It has its own IP address, but source IP would still be the 000. Destination IP, or I'm sorry, the source IP is going to be its own IP address, okay? As a source IP address, whatever the interface IP it is. And then destination IP would be again 255.255.255, because this machine does not have IP address yet, right? Same thing, source MAC. Source MAC would be its own MAC address, the interface MAC address, and the destination MAC would be the so there are two scenarios. If it is a router, right, there is the destination MAC would address would be still FFF. Just remember. But if it is server, okay, if it is a server based, then the destination MAC address would be the client MAC address, because this particular basically this machine's MAC address is known to the now DHCP server. So let's say for example this is Windows based server, okay, and if it is replying, the destination MAC would be this machine's MAC address. If this router is replying, it would be FFFFF. Just keep these two things in mind, okay. And next basically is what the after the offer, the DHCP request. Now the client basically sends the DHCP request, right? Stating, can I take this IP address? Because in offer, there would be a next available IP, right? So the host receives offer packet and it replies back with the request. This message tells the receiver that it's ready to accept the IP address, right? That server offered. This IP is still 00 and then broadcast. So just remember, when the DHCP request is sent from the client, it would be still the source IP would be DHCP server IP address. Uh, right, sorry, the source IP, because it doesn't have any IP address, it would be still it's still a 000. I'm sorry for this, but it is written here 000, and the destination IP would be broadcast 255.255.255. Layer 2 would be source MAC. The source MAC would be the computer's MAC address or the client MAC address, and the destination MAC address would be still, just remember, broadcast. Okay, just keep this in mind. Okay, the destination MAC address would be still server's broadcast. Sorry, destination MAC address would be the broadcast FFFF. Now they may ask, okay, when the DHCP client is known, now has known the MAC address of the server, why it is still broadcast? This is cross question that they can ask. Okay, you need to remember this, that if it is definitely it is broadcast, but this broadcast is only there when you have multiple DHCP servers available in the network. Okay, so it is broadcast. Why it is broadcast? Because uh maybe there may be a situation where the current DHCP server is down. Okay, so we will talk about in further discussion as on why basically it is broadcast. But let's get going with the DHCP acknowledgement. So finally, the server would send that acknowledgement stating that okay, you take this IP address. Before taking the IP address, obviously it will check its binding table, whether it has the that IP address is available or not, hasn't been given to any machines, and then finally it would send a acknowledgement saying okay, this basically IP address, you can keep it. And while basically sending it again, just remember, if it is a router, I am just taking with the two scenarios, one with the router and one with the um, Windows based server. Just remember, if it is a router, again I'm stating this, if it is a router, okay, just keep this thing in mind, that the source IP, from the DHCP server, right? The destination layer 3 would be always broadcast, and destination layer 2 would be always broadcast up to the acknowledgement, right? But if it is Windows based server, here it works differently. So they will have that. The source IP address would be DHCP source IP address, destination IP would be broadcast again. Source MAC would be the DHCP because acknowledgement is sent from the DHCP server, right? And then the destination MAC address would be DHCP client MAC address. Okay, but if it is router, again the source MAC would be its own MAC, but destination MAC would be still broadcast FFFFF, and this also would be FFFF. I would suggest open the Wireshark, right? And then see all those messages. It is very important. Okay, so that's basically the cross question that they ask. Okay, what information they will take and how they will take, right? I'm sorry. Other than that, what if the DHCP fails to provide the IP address? Just remember, this is where the question number is two. What is APIPA, right? So APIPA full form is Automatic Private IP Addressing, right? And it is a protocol or service which provides again IP address to the machine from the range. This is the range of APIPA, just remember, because this is also a usually asked question, as in what is a pipa and how it works. Okay, so you should, and what is the range also, just remember the range. And then what is a pipa? It also provides the IP address to the machine, but only when the DHCP server is unavailable. Just remember, if the DHCP server is available, machine will get the IP address from DHCP server, right? But if it is not available, right, this is where a pipa provides the IP address automatically from this range. Now, another cross question they may ask, can machine transfer, can machine with the APIPA IP address transfer the data to other machine? So the answer is yes. Okay, machine with the APIPA IP can transfer data, but just remember, only with the other device on the same local LAN, okay, within the LAN only, that also has the APIPA address. Just remember, means from the same range. Yes, they can transfer the data. Very important question. I hope this is clear. Pause it and just read it whatever it is written here. Okay. The third question they ask, what is DNS and how it works? Okay. So as we know, domain name system translates name into IP address, right? Why DNS? See, we all are aware of, it is hard to remember the IP addresses, right? But it is easy to remember the name. But computer machines, they do not understand actually the name. They understand binary, isn't it? So when we type, let's say in the browser www.networkerschamp.com, for example, machine doesn't know what kind of request it is. And this is where the DNS is required to translate this name into IP address. Okay. Then question is, who would do that? Right? There would be a DNS server. It could be local DNS server. It could be somewhere outside, internet DNS server, right? Where you have made all that entries. Okay. What sort of entries? So another question they may ask, okay, what are DNS most common records? Okay. Most common records. What they want to know Do you have understanding about the DNS records and all or not, right? So these are some of the records that I have listed here. A record, okay, a record that holds the IPv4 address of a domain. Just remember, as I mentioned, right? Let's say this is DNS server. Okay, in this DNS server, I would make a record saying, hey, networkerschamp.com has the IP address this. So the name corresponding to the IP address, that is called a record. Similarly, google.com, this is the IP, right? Facebook.com, this is the IP, right? A record, the record that contains the IPv6 address. Okay, this is used for IPv6. Canonical name record. Okay, forwards one domain or subdomain to another domain. It does not basically provide any IP address. It doesn't hold any IP address and name record, but basically forwards one domain to subdomain. When we say domain to subdomain, let's say .com, root level to the TLD, top level domain. MX record. Okay, very important, this MX record, because it basically holds that mail to mail server. So all emails, right, would have that MX record in DNS server. Basically, this email has this IP address, right, to reach. So that is called MX record. TXT record, let's it basically lets an admin store text notes in the record. It is just a kind of just for reference or description. These records often used for email securities. NS record, or you might be aware of NS lookup. So similar, stores the name server for DNS entries, as in who is the name server, right? What is the IP of particular that name? That is basically called NS record. And then PTR stands for pointer, provides a domain name in reverse lookup. So reverse lookup also happens in the DNS. This is for that it uses the PTR record. That is the answer of the question. Okay, and if you mention at least 3 4, you are done with the particular that question. All right, further to the DNS itself, they also ask what is the DNS flow. So just remember this DNS flow, it is again very important, because I promised you I'm not going to leave even a single question from any topic. So if we're talking about DNS, I'm giving you all possible answers they may ask, okay, off. So basically what happens when we type, let's say website, let's say networkerschamp.com in our computer, right? In the browser, our computer tries to find the IP address, right? So the first thing what it does, let's say that machine, so first thing what it does, it checks the local cache, the browser cache, right, to see if it is already known that IP address. In cache, local cache, you can easily find, okay, this was previously used and this is the IP address of this name. Okay, but possibly, let's say if there is no cache and this is the first time that you have entered this domain, right? If the local cache doesn't have that IP address, the query is sent. This is called DNS query. Okay, to whom? The DNS query is sent to DNS resolver to find the IP address. Okay, so this is where you see that it checks the local cache. Second, if it doesn't find, right, then it sends the host files, right? Host files as an, it basically checks and finally a DNS resolver to find out the IP address of particular that name. DNS resolver may check host files, but usually it moves on. Okay, if it doesn't have, obviously it will further query with the root server. Root server is the you know top level domain, I would say, as in just to query what is the top level domain of particular that name. Root server basically would say, okay, this is .com. Let's say if you type networkerschamp.com, so the top level is called here .com. Now this basically DNS resolver knows that who is my domain top level domain, right? That is called TLD. So resolver sends the query to root DNS server, points to the TLD server, which doesn't know the exact IP address. TLD server, then TLD means top domain, directs the resolver to authoritative name server for networkerscham.com. This basically says, hey, you can go to this authoritative, server who holds the, corresponding IP address of this name. Okay. And finally, it would query the authoritative domain uh, to have the IP address of networkerschamp.com. Authoritative name server basically sends the IP back to the resolver to the actually, machine, the one who sent the query. Resolver passes the IP address to our computer, and finally the computer knows the IP address. See, in the process wise and flow wise, it might be little lengthy, but it happens very quickly. Okay. So why I have actually added this DNS flow? Because you should be aware of what is authoritative domain, what is top level domain, what is root server, right? So if you don't know, just spend some time, right, and understand what are they, how it works, so that at least you are prepared, for the next question from the DNS itself. Similarly, here they may ask another question from DNS itself, saying, okay, can you explain me what is, if I am sending an email, how basically that email would be processed? Okay, though it is the part of actually SMTP, but again, I'm just explaining it here. So what happens when you, let's say, send out an email? There is a email server, okay? So emails, the request would go to the email server. Email server basically would check what email, what is the IP address of that email. So it would actually check the MX record. Just remember MX record. In MX record, it would find out the IP address, right? And finally, it would send it to another, maybe next another, email server. So just remember what I'm saying here. This is something SMTP. Why SMTP server? Because SMTP basically there are the mail transfer agents, right? So all email goes to the MTA. Okay. MTA basically checks the corresponding email, MX record, and then sends it out to the, do the normal routing and then sends out to the recipient. Okay. So the DNS flow. Again, what is DNS, how it works? DNS most commonly used records and DNS hierarchy. They may ask, can you explain what is DNS hierarchy? So this is DNS hierarchy, okay, or maybe the DNS flow. Okay. Next question they ask, what is FTP and TFTP? This is not, this is one liner answer to be honest. File transfer protocol, a trivial file transfer protocol, is a file transfer protocol between two machines. I'm repeating couple of times, right? But they may ask what is the port number. So FTP uses port number, let's say 20 and 21. They may ask why it is used, why it uses two ports, 20 and 21. This you should know. So 20 is basically used for data transfer and 21 for connection setup. 21 is used for connection setup, 20 is used for data transfer. This is the answer of the question. What is the port number of TFTP? 69. Just remember, I would say just remember the port number of all the, these services. Okay. Next question they ask, what is SMTP and what is the port number? So SMTP stands for Simple Mail Transfer Protocol. It's a communication protocol that allows users to send and receive emails over the internet. It uses the port number 25. Let's remember, how does SMTP work? Okay, so high level I have mentioned here. SMTP uses a store and forward process to move emails across networks to the correct email inbox. SMTP works with mail transfer agents to send and receive and relay emails. Just remember. Okay, and this is where you might find the MX record. Another question they may ask, what is POP3? So Post Office Protocol 3 is a standard protocol for downloading an emails, right, from the server to a client. This is one-way communication from server to a client. Just remember this keyword, from server to client. It uses the port number 110. It says it's one-way protocol. It only allows users to download emails, not to send them. Just remember POP3 is to receive the emails,
to download emails, where you can say SMTP is usually used for sending the emails. Okay. Um, Another question they may ask, what is SNMP? So SNMP is very quite, you know, big topic to be honest, but they want to know initially why do we use. So SNMP Simple Network Management Protocol is widely used protocol for network management. Okay, so you should know the concept of SNMP as and why we use. SNMP monitors and manages network devices such as routers, switches, servers, printers, firewalls, load balancers, etc. It operates within the application layer and port number 161 and 162. Okay, and used to monitor the network, detect network faults, and sometimes even to configure remote devices. Just remember one thing: SNMP is used basically for to monitor the overall network. Okay, it has components, mainly three components: SNMP Manager, known as a NMS, Network Management Station; SNMP Agent, it is a software management software, right? Installed on the managed devices. And then MIB, which is a database. MIB consists of information on resources that are to be managed. Some of the messages in SNMP, right? Get request, set request response, and trap. So get request basically it simply used to retrieve data from SNMP agents, okay, from agents to the server. Set request, it is used by SNMP manager or server to set the value of any object that it wants. Response, when sent is response to the set message. If someone has sent a set message, it is the response of set message. And trap. Trap is usually sent whenever there is a change in the network faults, anything, right? That time we use trap. And this is basically these are the messages. Before wrapping it up, going back to the DHCP again, they also ask what is DHCP relay. Just remember, very important question. DHCP relay. So DHCP relay, it's not written here. Maybe okay, I would do one thing. Okay, let me just explain here. DHCP relay. This DHCP relay is used when the DHCP server is in the not in the LAN. Okay, local LAN, right? And there is a layer 3 device in between. Let's say for example this is router and this is the complete LAN. Okay, this machine is sending a DHCP request, but your DHCP server is here. Okay, sorry for this design drawing. When this discover message is sent to the any layer 3 device, this device cannot, because that is a broadcast. Just remember, this router cannot actually send this broadcast message to another interface. So here on this interface, you would configure DHCP relay with the command. What is the command? IP helper address. And in address, you would configure the IP address of this DHCP interface or loopback, whatever it is. So what happens when the discover message is sent, router receives it or any layer 3 device receives it. It knows that this discover message to be sent on this IP helper address. It will do normal lookup, a normal IP lookup or routing lookup, and finally send it the discover message to the this DHCP server. Just remember, from here to here it will be broadcast, but from here to here it will be unicast. This would be all unicast because router does not do broadcast. Just remember, so it would do only unicast. And then the reply would be again, reply would be coming from this DHCP server to this IP address, the DHCP helper address, or on this interface, right? And then finally, the offer message would be sent to the client. Again, a request would be sent as a broadcast, but this would convert into a unicast, and then finally acknowledgement. Right? This is called DHCP relay, and it is widely asked question. I hope you guys have enjoyed this video, and you would utilize this video actually to understand and as in how to crack the interviews from at least from these topics, right? I would request everyone to subscribe the channel, right, and like, to basically get more such videos which will really help you on your interview preparation. Thank you for watching this video.